Very good morning. This is our fifth session on Business Research Lab. In previous four sessions, we have talked about the basics of SPSS, discovery stats, graphical procedures, and last week we talked about reliability. This week onwards, we'll be talking about all relevant tests which we need to conduct while performing research analysis. One sample t-test is the topic of the day, and one sample t-test is conducted when we have a given sample, and for a variable in a given sample we are trying to find out the mean and comparing that mean with estimated population mean, just to see whether the population mean and the sample mean are either almost the same or do they significantly differ. Let's have an example for that. We have an HR, you can say head of a leading accounting firm. He wants to acknowledge the average number of hours worked per week at the firm was significantly different from the hypothetical national average of 52 hours for accountants. The HR head randomly sampled 16 people from different divisions within the firm and recorded the average number of hours they worked per week over a 3-month period. The dependent variable in the study is the number of work hours worked per week. Now, the objective of, you can say, one sample t-test is to see whether sample differs significantly from some known or estimated population mean. And the data requirement we have is continuous dependent variable. In our case of this example, you can see accountants as you can say the dependent variable, the term, and you can say the dependent variable is you can say number of hours worked per week. So sample is accountants at the leading accounting firm, with dependent variable being how many hours they have been working per week. Okay. Now coming and talking about hypothesis, we have the null hypothesis and the alternate hypothesis. Null hypothesis will see to it that there is no difference between the population mean and the sample mean, or maybe you can say that it is equal to, you can say, the national average. So in that example of ours, the national average was 52 hours. So maybe you can say the population sample mean average will also be near to it. Whereas in case of alternate hypothesis, this you can say hours worked per week at leading accounting firm is not equal to the national average of 52 hours. So mu is not equal to 0. So we have the null hypothesis and the alternate hypothesis. And what we basically do is that when we are conducting this test, if the value of significance is less than 5%, then the null hypothesis is not accepted. And if the significance is more than 5%, then we are accepting the null hypothesis. So that's there. And if you look at the example here, you read that example, based on that example, we can create the research question. And this I have mentioned here is the number of hours worked per week for employees at leading accounting firm different from the national average of 52 hours. So that becomes the research question. So we are asking a question, is there a significant difference in the number of hours worked per week by employees at leading accounting firm to the national average of 52 hours? And then we have the data with us. So we have got the 16 participants, and then we have, you can say, number of hours they have worked per week. So without taking much of a time, what I'll just simply do is I'll copy this data. Control C I'm doing, copying this data, and I'm changing my screen to screen share to a new share. I'm going to a new data called untitled data. I'm sharing it for you, and I'm coming to data view. In data view, I'm just mentioning I'm just trying to, you can say, ensure that I mention this data. So I'm pasting it here. So this data, how many you can say hours per week these workers, these auditors have worked, you can say, in a given week in that leading firm, that is to be mentioned. So these hours have been mentioned. So 54 hours, 48 hours, so on till 56 and 60 hours by these 16 employees is being mentioned. Now I'll be, you can say, going for the variable view. So I'm simply saying duration. So this is what I'm saying, duration. How many hours they have worked, I'm saying it as duration. Okay. Number of weeks, hours per week worked by auditors. So this is the, you can say, this is the label to us. Values are not to be mentioned, because if someone is working for 55 hours or 70 hours or 60 hours, those hours itself are defining, are having a value, having a meaning. So auditor 1 has worked for 58 hours, auditor 2 has worked for 42 hours. So this itself is describing something. So this is basically scale and is ratio scale data. So measure I'm putting up as scale. Whenever the measure happens to be ratio scale, we are not to, there is no need to mention the value. Rather, there is no possibility to mention the value. But in case the scale is interval scale, we need to mention the value. So let's talk on that concept sometime later, though we have revised it previously also. So that's done to us. Now this is you can say the variable view. Data view, we can simply see that we mentioned the name of the variable as duration has come up here. Now we are going for this test one sample t-test. So we are going for analyze. So we are clicking on analyze. We are clicking on, you can say, compare means. I am moving to one sample t-test. This is done. Now number of hours per week is, you can say, the variable that is to be tested. So I click on this. Here we have got some options, and you can say it's 95%. You can say it's also given as 95. So we'll keep it as 95. But in case you need to make it to 99, you can say confidence interval to 99%. You can make it 99% to 98%, whatever you want to. But generally, you can say it is taken up as 95 only. So I'll continue with that. So that is by default. And what we need to basically do is we need to, you can say, keep it 95 only. So continue. And then maybe you can say next we can simply do test value. What is the test value we are going to have? Now if you look at the example we were talking on, we had that you can say value of 52 mentioned there. So that value of 52 I'll be putting up here, and this is the number of hours worked by auditors at the national average. So this is what we know. So this is it, and then I'll simply say okay. And if you can say I need to share the screen now again. So you can say, sharing the new document that is coming to us. So this is the document we are having. So number of hours per week worked by auditor, 16, you can say the sample size we are having. Mean is 59 something, 59, exactly 59 is the mean. Standard deviation is 7.14, and standard error of the mean is, you can say, 1.78. So that's done to us. So we know all 16, you can say, have been included. The mean is 59, exactly 59. Standard deviation is 7.146. Now, if you look at the things here, what we have got the answer as, the value of t is 3.918, and degree of freedom is 15, and significance is 0.001. Difference of mean is, you can say, 7. And how this mean value is coming, because the test value is 52. So 52 minus 59 is 7. So this is given to us. So let's look at the things again. The question had data about 16 HR, you can say 16, you can say accountants of a given firm, and that how many hours in a given week they have worked. So the data was compared to the national data, where we knew that the national data says that 52 hours of work is done by auditors in general per week. So we did the t-test or one sample t-test here, and when we compare the, you can say the mean we got, you can say for our data 16, you can say auditors of this given firm, the mean was 59, standard deviation 7.1, and then we had, you can say, the mean difference coming up as 7.7 because the test value or the national average or the population mean was 59, sample mean, sorry, population mean was 52, sample mean 59. So 59 minus 52 is 7. So that's the mean difference. Now the t value that we got was 3.918. Degree of freedom is 15 and significance is 0.001. So it's a very highly significant, you can say, differences there, and we can conclude this way that there's a significant difference among auditors of the given company and the hours they have worked per week as compared to the national average. We accept the alternate hypothesis at t-value of 3.918 and a significance of 0.001. The auditors of the given company work more, within brackets 59 hours per week as compared to national average, within brackets 52 hours per week. So that's how we can write the results. Now moving back to our file, just to explain the things, how we have explained the things over there. So that's it. I'm having this old share with you, and just move to this, that when is this one sample t-test conducted? The observations are independent. This means that these participants are independent and they are not influencing each other. And the dependent variable is normally distributed in population. So there is a normal distribution of, you can say, the dependent variable. Now 5.8, if you look at, these are, you can see, the checks we need to do. And this is already we have described, you can say, when I was doing the analysis part. So not much to be talked here. So you can simply remember these 6 points and remember this syntax of, you can say, conducting one sample t-test. And interpretation of result, we've already talked that if significance is less than or equal to 0.05, then null hypothesis is rejected. So if the value of, you can say, null hypothesis 0.05, 0.48, 0.32, 0.16, 0.001, or even 0.000, we will not be accepting the null hypothesis. In that case, the alternate hypothesis will be accepted. But if the value of significance is greater than 0.05, meaning the value of significance is 0.51, 0.58, 0.62, 0.62, or 0.83, whatever it is, we will not be accepting the alternate hypothesis, rather we'll go with the null hypothesis. Done. And one thing which is very, very important here is the, you can say, the effect size. Now effect size talks about that how large is the difference, how big is the difference, and effect size is given by, for Cohen's one sample t-test, the Cohen's d is given by d is equal to difference between mean of the sample and the population upon standard deviation. So if you look at d is equal to, in this case, 59 minus 52 upon the standard deviation which we got was 7.15. So 7 upon 7.15 is equal to 0.98. That's the answer we are getting. We also know that if the value for, you can say, D for one sample t-test comes out to be, you can say, 0.20, it is supposed to be, you can say, small effect size. If it is 0.50, the effect size is medium, and if it is, you can say, 0.80 or more than that, then effect size is quite high. In our case, we have seen the value of D is equal to 0.98. Therefore, the effect size is quite high. So that we should remember the effect size. And finally, you can say, how are we, you can say, going to write results? So the same answer I've written, I've tried to, you can say, answer the question and write the result. Employees at leading accounting firm, M is equal to 59 and standard deviation is equal to 7.15, work significantly more hours per week than national average of 52 hours. And T, within brackets 15 basically means degree of freedom. So degree of freedom is n minus 1. So 16 minus 1 is 15. T within brackets 15 is equal to 3.92. The value of P is less than equal to 0.05 and D is equal to 0.98. Here, I suppose the mistake that I've done is I have made it, you can say, is P is less than, you can say, is less than 0.05 and D is equal to 0.98. So that's the, you can say, that's the question we have done, example we have done for one sample t-test. Hopefully, I suppose you have understood things. Please go through the another video which I'm sending regarding the example for the same. So thank you.